Right now, without even trying, your brain is burning through roughly a fifth of all the energy your entire body uses today. Not your muscles, not your heart. Your brain quietly consuming that much fuel while you sit here doing nothing more demanding than listening. That number should sound absurd, and yet it is the price your species has been paying for millions of years, ever since something set off a runaway race to build the most expensive organ evolution has ever produced. For most of hominin history, brains barely grew at all. Early ancestors like Australopithecus, walking upright but still deeply ape-like, carried brains only slightly larger than a chimpanzee. For roughly a million years after that, brain size crept forward at a painfully slow pace. Then something shifted. Brains began expanding faster and faster until Homo sapiens ended up carrying an organ almost 3.5 times larger than what Australopithecus started with. The question anthropologists have argued over for decades is simple to ask and brutally hard to answer. What actually flipped that switch? One leading answer comes down to what was on the menu. Paleoanthropologist Juan Luis Arzuaga, co-director of the Atapuerca excavation sites in Spain, has argued that the shift toward eating meat was one of the single most important events in human evolution. Brains are metabolically expensive. Building and running one costs enormous amounts of energy, and for most of early hominin history, that energy simply was not available. A diet built mostly around tough plant fiber requires a long, heavy digestive system to break down, and that system itself burns a huge amount of energy just to operate. Once ancestors started eating more meat, rich in fat and protein and far easier to digest, something interesting could happen. The gut could shrink, and the energy that used to go toward digestion could be redirected somewhere else entirely, toward a brain that was about to get much more expensive to run. But diet alone cannot explain the full story, because a bigger brain does not automatically mean a smarter one. This is where the second piece of evidence gets strange. In 2016, a research team led by physiologist Roger Seymour at the University of Adelaide, working with Edward Snelling at the University of the Witwatersrand in South Africa, took a completely different approach to measuring ancient intelligence. Instead of just measuring how big fossil skulls were, they measured tiny holes at the base of those skulls, openings where arteries once passed through, carrying blood up into the brain. The size of those holes reveals something remarkable. It tells you how much blood, and therefore how much energy, that ancient brain actually needed to keep functioning. What the team found was startling. Over roughly 3 million years of human evolution, brain volume increased by about 350%, but the rate of blood flow required to fuel that brain increased by almost 600%, dramatically outpacing the growth in size alone. In other words, brains were not just getting bigger, they were becoming far more energetically hungry per unit of size, running hotter and faster than their size alone would suggest. That gap between size and blood flow may be one of the clearest fossil signatures of rising intelligence that scientists have ever measured. This method mattered because it solved a problem anthropologists had struggled with for decades. Brain size alone had always been treated as a rough proxy for intelligence, since the number of nerve cells in a mammal brain tends to scale with its overall volume. But that assumption had never quite explained everything. Two species could carry similarly sized brains and still differ enormously in how they behaved, what tools they made, or how they solved problems. By measuring blood flow instead of raw volume, Seymour and Snelling were effectively measuring how metabolically active that brain tissue actually was, which turned out to track far more closely with the archaeological signs of growing cognitive complexity, from tool use to social cooperation. Now picture what this actually meant for the hominins living through it. A small band moving across an open grassland, carrying bodies that were, brain for brain, running an engine more demanding than anything that had come before it. Every single day, a huge share of the calories that band managed to hunt, gather, and carry back to camp had to go straight into keeping that expensive organ powered. There was no room for waste. Feeding the brain came first, ahead of nearly everything else the body might have wanted that energy for instead. Here is where the story takes an unexpected turn. It was not only diet and blood flow driving this shift. Climate played its own brutal role. Fossil evidence shows brain size stayed essentially flat for close to 1 million years, then suddenly jumped forward right around the time Earth entered a series of severe glacial periods, brutal ice ages that repeatedly reshaped the landscape. Cold, unstable environments punished anyone who could not plan ahead, cooperate closely with others, remember where resources had been in past seasons, or build fire and shelter reliably. Under that kind of pressure, a slightly smarter brain was not a luxury. It was the difference between a family surviving the winter and one that did not. Some researchers believe this exact stretch of harsh, glacial climate is what triggered the emergence of Homo heidelbergensis, and later Homo sapiens, both marked by unusually rapid jumps in brain size compared to their ancestors. So diet supplied the fuel, climate supplied the pressure, and somewhere in between, brains became not just bigger, but dramatically more expensive to run, all in the name of staying one step ahead of extinction. And now for the twist that very few people expect. Human brains are not actually the biggest they have ever been. According to research published in 2021 by paleoanthropologist Jeremy De Silva at Dartmouth College, average human brain volume peaked at around 1,458 milliliters, sometime in the last 100,000 years. Since then, it has been quietly shrinking, down to roughly 1,304 milliliters today. That is not a small dip. It is a meaningful decrease, happening in a species that supposedly keeps getting smarter with every generation. Nobody knows for certain why this happened, but one leading idea is genuinely strange to sit with. As human societies grew larger and more interconnected, individuals stopped needing to personally store every piece of survival knowledge inside their own skull. Instead, that knowledge could live outside the body entirely, pass through language, then writing, then books, then entire institutions built to hold collective memory, so no single brain had to carry the full weight alone. In a sense, humans built an external hard drive out of culture itself, and offloading memory onto it may have quietly reduced the pressure to keep growing an increasingly expensive organ. There is another possible piece of this puzzle worth mentioning. Some researchers have pointed to changes in body size over the same period, noting that humans today tend to be slightly smaller and less physically robust than the Ice Age populations who carried those larger brains. And brain size does scale to some degree with overall body size across mammals. Others have suggested that a smaller, more efficiently wired brain might process certain kinds of information just as effectively as a larger one, the same way a smaller, well-designed engine can sometimes outperform a bulkier, older model. None of these explanations are fully settled, and that lack of certainty is itself telling. Even with modern imaging technology, genetics, and thousands of measured skulls, scientists still cannot say with total confidence why the most celebrated organ in human evolution has been quietly getting smaller. Think about what you are doing right now, in this very moment. You are not memorizing which valley had water 3 seasons ago, or which plant root was safe to eat and which one would kill you. Your ancestors carried that knowledge inside a brain that cost roughly a fifth of their entire daily energy budget just to keep running. You outsource an enormous share of that same cognitive load to your phone, to search engines, to notes you will glance at once and immediately forget. Every time you look something up instead of memorizing it, you are living out the exact same pattern that may have shaped the size of the organ sitting inside your own skull. Your brain became this expensive because feeding it correctly and eventually surviving with it was worth an almost unbelievable metabolic price. And now, quietly, some of that same organ is being handed off again, this time not to books or institutions, but to devices sitting in your pocket. The story that began with a hungrier brain chasing meat across an ancient grassland may still be writing its next chapter right there in your hand. If you enjoyed learning how ancient humans really lived, hit subscribe. Stick Age brings you a new story from deep human history every week.